So, ladies and gentlemen, this is the first produced 39 Gripen Eco aircraft. This one that the maiden flight was performed in this one. 39-8, as we call it, the first test aircraft of the Gripen E. We have in the hangar in that direction we have a -9 and -10 also. -9 up and running, and -10, that's we're talking about weeks until that maiden flight will be done also. During this year we continue the program, so the first serial production aircraft 6001 will also be flying this year, and then it's 6002, 6003, and it will go on like that. When we talked about this one, it's not just the first one, it's the most heavily equipped with the data capability for in real time distributing humongous of data down to the Houston facility, the test facility, with all my smart colleagues, the engineers, will provide me with information while flying the Gripen, but also supervise and monitor all the specific data that's needed for the test flight. As you all know, in the beginning, it's a lot of extra attention to all the system. So we have the hydraulic people, the fuel people, the engine people, to just monitor and see that everything is up and running as we're predicting, but also that we maintain a high level of flight safety during the flight test, so we're not overstretched the risk index that we predicted for a certain sortie. Of course, along the day, when we proceed with the program, it will be less supervising because we're happy with all the data, and it will be more and more tactical test flights performed in the aircraft. In the beginning, when you have a brand new aircraft, you need to see that the characteristics of the aircraft, what you actually see when you're flying, is correct to the model, because we have so to say a super Gripen in the software in the computer. So we have a model of what will be the characteristics when we're flying in a certain altitude, in a certain airspeed, in a certain G, or all the forces on the aircraft at all time. It's predicted, but also supervised in real time while we're doing the test. So the model running with all the thousands of data, and also we have the data from the actual test aircraft, and it's monitored in real time by people, but also by computer against the computers, to see if there's any delta characteristic between the model and the aircraft. And we've of course defined a certain volume of the difference. So if we're expanding that limit, it will be a abort call if that would happen during the flight, to sort out what happened over there, because it's a mismatch in the data, or if we go home for a deeper analysis. So that's one thing to contribute for this flight safety when we're performing a flight test. All right, what more? So you will find a lot of extra things on this aircraft to be able to measure all that. In a serial produced aircraft in the future, of course, they don't have the measurement of the heat building up in the nose wheel, or additional stretch point of the wings and all that, because that's just what it is. It's a test aircraft. So we see that everything works as is supposed to be working. So it's a lot of add-ons along the aircraft. So that's really important. Of course, It's a deeply complicated flight test plans because we are doing all the tests in a proficient way, but also a cost-effective. So we're not go airborne and just fly. Okay, today it's a fuel test. Tomorrow it's the engine test. Of course, efficiency, that's taken care of. That every subsystems of the aircraft will run simultaneously and get the correct data for the actual sortie. Some sorties high altitudes, low speed, high altitudes, high speed or supersonic. That depends what the purpose will be for the day. But all the personnel involved in the test team is represented for different kind of subsystems. Sometimes it's more to the, let's say, for the handling quality or flying quality of the aircraft. And sometimes we more and more go for the tactical side also now to see how everything is working with the secondary power supply system and the secondary cooling systems and everything works in that perspective also. You need to do all that and to validate the actual data before you just start running in a direction, for example, for the tactical part, if you don't do all the basic part in the beginning. And we've done that and we're still doing it in many sentences to open up the volume totally according to the contract. Yeah, we always have fire and rescue service on the base, and during some ground test in the beginning, with the first run-up of a system, we could increase the readiness level of a certain units. But I'm not saying that we're doing high-risk test every time we're flying this one. It depends on the actual flight test sortie, what we're supposed to do. If it's the first time of something, sometimes we add, for example, different kind of weather minima. Sometimes when we started to do weapon payload in different kind of configurations, it's a good thing to decrease a little bit for the wind and weather settings to see okay, everything works as it's supposed to do, and then you start to open up the volume again. For a clean aircraft, could be open up like that, but if you're doing a heavily asymmetric payload, handling qualities and flying quality verifications, then you start from the middle, so to say. And we're doing that during the time. It could open up and be slightly narrowed, depends on the test for the day.
Så det är ingen så här helikopter som är särskilt standby när ni är ute och flyger?
Nej, inte ens, not even the first flight. So that was the basic fire and rescue service here.
Is test flying, is it sort of dull flying? You take it really easy and take easily off and land and try to take care of with the plane, or do you end up doing all the tricks? And
you know, if I would describe the first the maiden test for this one, of course it's a narrowed in what we're allowed to do because that's strategically, and the risk index in itself is quite high because it's the first time ever in a new configuration and so on. So of course he didn't just pull a stick like that because he thought that would be fun. We have limitations to stay within, but then pretty fast envelope expansion is planned, and we're following the line, so to say. But sometimes when you add a new system, you could decrease it again and then open up again, depending on what you're doing. Yeah.
When the envelope is opened, opened.
Yeah. When?
Yes.
Good question. Well,
you have some plans.
I mean, we have a schedule to deliver the Gripen as initial operational capability and full operational capability.
Yeah.
And I think I'm not totally updated, so I'm not able to answer that right now with a certain date and so on. But we're following on the test plan with our test aircrafts, and we proceed really good about the envelope expansion, so to say. Yeah.
thus far you've done the IRIS-T and drop tank separation in flight.
IRIS-T and the drop tank,
Yeah.
yes.
But
Yes.
not the rest of the...
You know, the different kind of weapon separation tests, it will be, I mean, the operational CD, we have a lot of different munitions to that one, and now we increase it even more. So it will be a lot of weapon separation tests, but also not just to separate or drop a drop tank or something like that. It will be all the logic behind it, how all the information communicating in between the missile back and forward in a certain missile, and so that's the whole circle of from launch until a good hit. That's a long-term plan to be able to take care of that and show the customer that we're able to do according to the specifications.
What's the cockpit configuration in this one? Is it the wide area display already? Or?
This one is the 3 screens because we didn't put in the wide area display in the first aircraft, and the reason for that was that we're quite familiar about the architecture and all that, so we didn't take all the step at once. So this one mainly the flight test in this one is handling qualities and flying qualities, and then the tactical part will be more involved in our other test aircrafts. Yeah. Okay. So the Gripen E, I will complement with information about it's a test aircraft in itself, but I will also describe what we will find and how it's look like when we're doing the round trip here. AESA radar with a swash plate. It's a game changer in comparison with the previous versions. What's able to do and do it simultaneously for air-to-air and air-to-surface arena. To create a SAR image of something despite of the weather condition, to have a high resolution image and doing something from a reconnaissance point of view or for a target assessment or a BDA or something like that, and the tracking performance and to pick up air-to-air and air-to-surface targets in a long distance. That's as my presentation said, from a sensor perspective, that's a really game changer. Up top, now it's not mounted. It's a coverage right there, right now. But here you will find the IRIS-T, the passive sensor for picking up IR bubbles of the targets in the surrounding. Also creating an IR image as a complementary sensor that we don't have so far on the Charlie Delta. Okay? Here's the gun. 27mm Mauser. We talk about 24 rounds a second. So that's quite interesting. You know the
Can you please?
Yeah. You know, highly reliable and high accuracy, and it's one thing. If you're not able to predict, it's a good thing to have a lot of ammunition to just do. Eventually, you will hit the guy, or you are able to predict. And so I mean, in a normal burst, we do it 1 to 1.5 seconds to have a hit. And we're talking about a couple of kilometers at the maximum range.
Has it been fired yet?
This one? No. Not this one.
How much ammunition is there room for in there?
It's 140 rounds. Yeah. Okay. On this test aircraft, this is the missile air warner MAV system that will predict the air bubble popping up in the surrounding, connected to the threat library to do countermeasures against the threat. So, for example, we have different kind of programs that will automatically activate directly when it's an incoming missile. And this is one of many antennas on the aircraft to be able to pick up that kind of information, distribute it into the computers of the EW system, and start to react automatically. So this is for my colleagues' briefing concerning the EW. That's the really nearest surrounding of your last chance. And that's if the bad guy's using something on the shoulder and launching it just by predicting you like that. So it's not connected to the radar system, or it's just a handheld missile incoming. And then we're talking about one or couple of seconds. So it's a very reactive system to pick up the air bubble and do something about it. And you remember the slide before with like a onion. That's the inner version, and then we have different kind of layers. So we're doing proactive EW on long distance, and we have different versions of techniques until we reach the inner bubble, and that's this one.
So it detects the missile exhaust.
Yes.
Signature.
Yes.
Yeah.
Yes. Okay. Here. You know, this is one of the many good things that we brought from the Gripen CD into the Gripen E and F. And this is the canards. And we are a very unstable aircraft. And why are we an unstable aircraft? Why is that a good thing? Well, it's a really highly maneuverable aircraft, and it's quick turns and rolls, and handling quality of the aircraft. So the maneuverability. It's not the flap settings or something like that. So the pilot would go flap setting like a conventional aircraft. This is totally 100% digged into the flight control system. So I don't manually do something to have something going on with the canards. When we're flying, if we compare it with if you're sitting in a car as a passenger and you put down the window and you have the pencil and you have you take the back part of the pencil, put it in the back part, and then go out in the airstream, and then you let the pencil go. It will take a split second, and then the pencil will just go like that, because you're not able to maneuver around in the back part of the pencil to make it fly outside in the airflow. Yeah. The wings and the rudders and the canards makes Gripen fly like that. So when we're creating a turn or a pitch movement for something, it's actually creating a disturbance of the balance of the aircraft. So the pencil will start to go like that, but it will be outmaneuvered once again. So it will be a continuous turn instead of a departure. So this is digged in to take care of the pitch capability of the aircraft together with the wing rudder. So we lift ourselves in the front part of the aircraft, creating less drag. And that stands for not just the air combat maneuvering. That stands for as a kind of flap setting when you're doing supersonic in high up and in high altitudes, but also compensate the balance and CG issues that you always find when you're putting up a lot of weapon on the aircraft. So this at all time looks like that. When you're going for landing, it will be canards doing like that. So it's a kind of flap setting, and once you're doing a touchdown, the canards will go like that to make a short strip landing. Yeah, aerodynamically doing like that.
As a speed brake.
As a speed brake like that, and giving even more pressure in the front part of the aircraft, and helping the nose wheel to be more brake efficient.
That's automatic?
Everything is automatic. Everything is automatic.
Did the CGs change much as you put in a much heavier engine on the E-model?
We need to recalculate everything on this aircraft because we changed so much. The weight and balance thing, that's a totally another thing. So it still looks like a Gripen, and we picked up the goodies from our inheritance and bring into this one. But we couldn't just say, hey, look, pretty much the same, let's go for it. Yeah. Because it's a totally new wing, reinforced wing to be able to carry more weapon load. So we have a 2,500 kilos weapon load, and that's a lot. So they are reinforced, so to say. And also, if we start to look in this area, here's the undercarriage, and the engineers of Saab, if compared with the Charlie version, we added about 40% extra fuel internally, just by, I say just, by redesign the undercarriage in a smart way in comparison with the Charlie.
It used to go into the fuselage.
Yeah. Before that was in the fuselage, but now they're, so to say, spread out a little bit more. So it's a lot of redesign work, but also, of course, to the more heavy configuration because of our capability to have more payload on the aircraft. They need to reinforce the gear also. And also, by spreading them out, we have now 3 weapon pylons beneath the belly. Okay, this is what we call pylon 1, the outer pylon of the aircraft. We have 3 pylons each wing and 3 pylons beneath the aircraft and 1 in the front also for example, LDP, light laser designated pod. Out here, you could have a different kind of IR missiles, but inside this, if you remember the EW presentation, here's happened a lot. It's not just antennas out here. It's actually heavily involved with the not just antennas. It's also heavily digged in the air warfare system for the jamming part and the 360 bubble coverage as an antenna also. Also the effect of everything, according to the presentation today, generated that we rebuilt the cooling system because it will generate a lot of energy out here. So we have a secondary cooling system in the aircraft also, running through the wings out here to cool down the stuff and the energy building up out here.
Vilka temperaturer handlar det om?
Oh, I don't know. But it's obviously we need to do it. Let's say theoretically, if something happens with that one, we have monitored the temperature here, so it will be a graceful degradation. It's not just a clean cut if something happens. And that stands for the whole concept, because that will increase the sensitivity of the mission success. If you have a subsystem telling, hey, I'm not fully working right now, that shouldn't cancel the whole aircraft and bring it as a hangar queen for a week. Graceful tactical degradation, that stands for, okay, the system will tell the pilot, I'm degraded, and here what's in what kind of area I'm degraded in, but I'm fully functional in the other stuff, and it's not flight critical. So you're still able to operate. And for example, if we have cooling problem for some reason, a certain day in the future, it will be a graceful degradation, and you're still operational to a certain limit, and then you automatically the system will shut down before it will be any damage. Now this aircraft, they're doing some checks, a planned service, so to say. So that's why it's looked like this. I can see there for sure have done some checks for the APU, because this is the APU hatches here and here. Bring in, sucking in the air and then pushed away on the other side. And it's actually just a small jet engine back there. So we don't need any external power or things if we end up in a dispersed base, war base, something like that, or when we're standing on the apron. So that's a really good thing. Generating all the electrical need and power supply, hydraulic supply, and all that before we start to run up the engine. So that's one thing to play with, or to use the level of readiness when you're doing QRAs. One level will be that you're standing on APU. You shorten the time it will take until you have a takeoff. That battery will be charged when we're flying. So after just 15 minutes, it's fully charged once again, and you have a numerous of allowed startup for the APU without any charging. So it's always fully charged, even in really low temperatures. Then you have the startup sequence for the APU, and once APU starts running, then it's up and running. So you could start to do changes in the pre-planned mission that you have distributed with like a USB from the mission support system. And you could see with the links, different kind of link system, I'm able actually to see when I'm sitting in the aircraft with the APU running, waiting for my takeoff in an operational environment. I can see the different kind of fights over the whole Sweden, the coverage of the whole area of Sweden. So I could pull my moving map, for example, up to the northern part of Sweden, zoom in, and I could just see 2 versus 2 dogfight with a symbol and see what's going on while I'm standing here in Linköping, because that's a network-based and distributed information. And that's a good thing. In wartime operations, when you're waiting to be refueled, put up weapons, you are able to see what's going on in the battle area, operational area that you're supposed to go to in 10-15 minutes maybe. You can see, how it looks like from the fighter link distributed within the net down to you. So you're prepared of what's supposed to see when you get airborne and jump into the fight. That depends on how the customer want to build up the net. But I'm used that we have that kind of coverage. So even if you're standing on the apron, that you're picking up the net and be able to see friends and foe, and could move the cursor to get even more information. What kind of threat is that symbol? You can read the speed, altitude, what kind of platform it is. You can see what kind of weapon engagement zone that object has, and you can see how your friend's taking care of that threat also. So you can follow the fight and be more well prepared in real time.
How long would it take from Linköping to Lapland, let's say, the northern border of Sweden?
Northern border of Sweden. Well, if we're doing a supersonic, it's we talk about 50 minutes, 45 minutes maybe. And that's the northern part. Here, to fly the Gripen, it's Mach 0.9. That's a standard. If you don't need to launch a missile or drop a certain kind of bomb or something like that, it's like doing 90 kilometers an hour with your car when you're driving back home. So that's Mach 0.9. From Linköping up to Luleå, that's pretty far up in Sweden, and that will take about 50 minutes, 45-50 minutes.
Can you do supercruise with maximum weapon load?
Well, we need to find out. I mean, maximum weapon load, we have some really big things under the wing sometimes, producing humongous of drag. But we have supercruise capability in some extent, and
with some sort of weapon load.
For sure, we have. But to say just yes on that question, I'm not able to say that.
Have you been flying during night time so far?
Yes.
Okay.
With the Gripen E? No, we haven't so far. Actually, nothing will. We wouldn't. It's allowed to fly, but from a flight test efficient way, we haven't done it so far, because we managed to do it in daytime operations. Because of the envelope expansion, it's not interesting to do it during the nighttime, so to say.
As a pilot, why do you feel that plane in front of us is better than Russian Suhois, for example?
Well, as I'm used to say, I'm not talking bad about other in these situations. I'm only talking good about this one. Yeah.
Okay.
But
tell us something
you know,
about.
Yeah, but you know, we are. You know, if you see a Gripen flying, you could give yourself a question: what kind of mission will that aircraft be performing right now? You're never going to be able to say anything about it, because it's a air-to-air mission, air-to-surface mission, or a reconnaissance mission. It could be the same during the same mission. So the assets with the Gripen to be able to perform a deep strike intercept or EW mission to get far into another country's SAM system, or to make a defensive counter-air back home, with the fighter capability with this one, with the decision support and HMI, that's totally awesome. That will be provided with that kind of information. At the same time, you have the missile, both for air-to-air and air-to-surface, that we know that we are far and beyond the capability in that area of the known opponents. So that's a pretty good match. But also all the new sensors that we have here, and the range, or you could swap the range extended range capability to fly, if the environment allows it, to extend the time on station. It's a lot of patrolling going on, to watch the border, to watch to be present, and then we extended the time a lot with this one because of our increased fuel amount.
Have you fired missiles from air to surface?
Air to surface, yes. Yes, I've done that. Guided and unguided also. So we have a lot of different kind of bomb and glider bombs and also missiles. We have. And according to the program, it will be the tactical part with the Gripen E program will just increase now to continuously clear off weapon by weapon, so to say. So we have a full integration according to the specification.
So you can say that you have done the basic homeworks and now you're developing the ability.
Yes, in the early part that was a lot of things to prove not only for ourselves or for the customer, it's also for you know, the national and international regulations regarding flight data and our new architecture in the aircraft. You know, we talked about all the computers and applications and how everything works in the avionics structure. That's so brand new, so we need to put a lot of effort to show that we have the reliable data and we will have the certification of our product.
What do you think about quality of Russian fighter program? Can they match innovations of Western defense forces?
Well, I could give an answer on that one, but I will pass because I think that's something for you to decide actually, and that would only be ridiculous for me to say that we're outperforming in that and that and that and that area. I think it's better to just give you a really deeply brief about everything that we're able to give you information about, and then it's up to the potential customer to validate. It's always like this. If someone out there saying our product, we are best, this and this and this and this and this area, the reliability, I don't think so. So what are you not telling me the truth? And to what extent are you not telling me the truth? So that's not a good thing to doing business in. We declare what we're able to do and how it goes and where we're going. So it's up to the customer to evaluate us. Back here we have the speed brake extended like that. Going out there, it's a 90-degree aspect angle to the airflow. So if needed, we could just hit the brakes, and for sure it feels like hitting the brakes like a race car.
Okay. How many G?
Yeah, in that direction.
Yes.
Yeah.
Like
no.
in race cars.
Yeah. Well, it's not that many G's. No. It's for example, if you're joining up really fast to another guy and you have a closure speed like that, you go idle and it's not enough, and you put out the brakes, it will stop you on the wing. So it's a good thing every now and then to use.
So there is tactical use also.
Yeah,
in air combat.
In air combat, sometimes also could be something to figure out if you want to stop really fast.
The Cobra.
No. Cobra, in our perspective, is just a good way to get rid of a lot of energy.
Okay.
Up in the fin, that's a jammer. Brand new jam, because we have the jammer capability in Charlie Delta version also, but this one is improved and new capabilities.
Thruster version får den här överhuvudtaget?
Nej. Because on thrust reversing, that will cost you so much weight actually. To have that kind of capability of an aircraft like this, that will affect the thrust-weight ratio too much, we think. We had it in the Viggen system, a heavier aircraft, but No. But we have a turn radius actually. So if I'm doing full left pedal, performing a taxi, my left wheel will go backwards.
Oh.
Yeah.
What about the thrust vectoring capability? It's not usually implemented in Western planes.
No. Well, that's a decision to make if you think that's a good thing. Obviously, we've seen solar displays when you're using the thrust vectoring, and that looks really cool, I think. But you need to think about what's the. It will cost you a lot to have that kind of capability, and is it worth it? It's up to the customer to decide also, because if you implement the HMD capability and a really nasty missile for the close combat area, if you have a conventional aircraft and you have a highly maneuverable aircraft with thrust vector, and you don't have that sophisticated system, it will be so easy for someone to do like that and performing a shot. But if we're doing like this and put out the needed sensors and the helmet display and also a really good close combat missile like the IRST, then it's something else. Then it might cost you a lot, and maybe it's not that advantage, and you got a better system and get more bucks for the money. Another interesting thing is that the right side of the Gripen is pretty similar to the left side.
It's very
So we could speed up the right side. It's not so interesting. To the service they're doing right now, they haven't mounted every pylon here. So it's when we're flying around with weapon pilots, it's stuck more on the wing, so to say, but also in the undercarriage. There's 3 extra pylons, but it's not mounted here right now. That's the one. And you put a pin like that, and you have like a fork like that, and then you tow the aircraft.
Just any car can do that, or a design truck.
Well, if you don't have anything else, but it's the. Yeah, I mean theoretical. If you have a couple of guys like me, no, I'm just kidding. But it's manageable to release the park and brake and then start to push it. But it's not, of course, the concept. When you tow it, it's a tow truck outside. But I'll see if we have it here. We can see if we find out. You can see the tow bar. Yeah. But it could be connected to a truck, to a car, to something else, actually.
Can you adjust the air intakes based on the airspeed?
Not the air intakes, no. No need, actually, for our design. I know what you mean, but it's not within the design, because we got enough air to support the engine at high altitude and low altitude, so the difference between that one.
So when you don't have a special intake, how can you say that you are flying 2 Mach?
Mach 2? Yeah.
It's not possible.
It is. We flew Mach 2 with a Draken, actually.
Yes.
Yes. Yeah, that's possible.
But it should be a little bit movable intake.
No, not on Draken. No. It's the air intake. That's designed actually to be big enough in a low speed and to be small enough in the high speed. And that's the design that works. That we're able to pick up Mach 0.2, Mach 2.0, 2.0. Yeah.
Just how on earth do you fly Mach 2 with a Draken?
Well, we did.
Downslope.
But that wasn't with fully weight configuration with weapon. That was a clean aircraft. That was designed actually, the Draken, to intercept high altitude and high speed. But maybe the extent of the flight time maybe wasn't that long. But that was the design back then.
Okej.
Yeah,
Har vi done nu eller?
I'm done with the
One
tour.
photo.